All right, everybody, welcome to lesson number 4. So in lesson number 4, we're going to be using samples to estimate population parameters. So basically, the rundown of lesson 4 is we're going to take something that's a sample and say, we now know this about my sample, so now we can say it's probably true about the population too. We're making estimations or inferences, whatever word you want to say that allows us to say that we're predicting something from a smaller sample. So the opening exercise, it kind of goes through why we need to do this. So it says a team of scientists wants to determine the average length and weight of fish in the Hudson River, determine a population of interest, and a sample that can be used to help answer their question, and explain why a sample must be used. So first off, the population of interest. That's all fish in the Hudson River. A sample, well, a sample is going to be a small amount of those fish. It might be, we'll say, 80 fish. From the Hudson River, and we'll say we want to make sure that we randomly select them. So, why do we have to use a sample to determine this answer for average weight and length of fish? Well, the reason why is I can't physically possibly have every single length and every single weight of every single fish that currently exists in the Hudson River. It's impossible. I'd have to catch every single fish that lives in Hudson River. I would never be able to do that. So determining the true population average and weight is going to be impossible. So the only way for us to actually figure out what that population's average weight and length might be is to take a smaller sample and estimate from that sample what we think the population might be. And we're going to spend a lot of lessons, actually almost the rest of this unit, doing that. All right, today's the first day, or this lesson's the first lesson where we're introducing this idea that a sample could tell us something more about the population. So another example here is showing us why samples are important and how we can determine a good sample versus a bad sample. So it says, for example, suppose you were running for campaign manager. You are the campaign manager for your friend who's running for senior class president. You would like to know the proportion of students who would want to vote for her on election day. The class is too big to ask everybody. It's 314 students. So what do you do? So there are 3 different options here, and we want to figure out which one we think is the best one, which ones might have bias, or which ones might not be a good representative sample of the senior class. So the first one says, poll everyone in your friend's math class. Now, although this would probably mostly get seniors, which is what we want, it's not going to be a representative sample of the entire 314 seniors. That's one negative. Another negative here is not all 314 seniors had a chance to be in the sample. Right? Depending on your friend's math class, if they're an accelerated student, well, I'm only going to be asking accelerated kids. If they're not an accelerated student, I'm only going to be asking non-accelerated kids. What if your friend is in a math class, but a lot of seniors don't take math at this certain school? So there's a lot of variability there that's causing this method to not be good, right? This is not a good method for sampling. Although it would get a sample, it wouldn't be a representative sample of the seniors. The second one says, assign every student in the senior class a number from 1 to 314. Then use a random number generator to select 30 students and poll. This would be the best way of doing it. This would be our best sample. I'm randomly selecting. I have all seniors are included in the potential to be part of the sample. making sure that that sample is representative of the entire senior class by having all 314 seniors be part of it. This is the best sample we possibly can have. It even says try this on your calculator. There is a random number generator tool on your calculator. I use it in class all the time to call on you guys. We also can just Google random number generator, and there's a bunch of apps that pop up, and you could probably get something right on Google there that'll randomly select numbers. And it is the best way to take a sample of a large number of people or students or whatever you're taking a sample of. This is the one that your campaign manager should go with. Let's take a look at the last one and explain why that one might not be good. So it says, ask every student at the football game on Friday night. So since it says the word every, right, this is not a representative sample because we're asking people that aren't even seniors. We're asking juniors or freshmen or sophomores whether or not they would vote for this person. That's not representative of the sample of people that are going to actually be voting. Right? Also, we can say another bad thing about this is it's somewhat biased, right? Only football fans are going to be part of this sample. So what if your friend is not one of those kids that's into sports? Well, you know, those kids that are into sports might not have a favorable liking of him. So this would not be a good sample. It's biased because it's only people that like to go to the football game on Friday, and it's not representative of the senior class because there are some students that are not in the senior class there. Okay. This part on the top of this page is really what we're basing everything on for the next like 4 lessons. So I'm going to do a decent amount of talking right now, and then we'll look at a couple of examples of what I'm trying to explain here. But if you don't understand kind of the differences between the two things I'm going to outline here, definitely email me and I'll try and explain them to you better. Right? So it says, when conducting a statistical study, a question is asked about a population of interest. A population proportion or a population mean are examples of unknown parameters we are interested in finding out. So what does that mean? Population proportion is the proportion of a population that favors something. So we can say, 70% of the students in Cornwall High School like going to football games on Friday night. That's a population proportion. A population mean, that would be an average of the whole population. So you could say students in Cornwall eat fast food on an average of 3 days a week. That's an average. And both of those things are talking about all of the students in Cornwall High School. So their population statistics. Now, when we have a population quote-unquote statistic, we call it a parameter because we really don't know the answer. It's an unknown parameter, right? If I was to say 70% of students at Cornwall High School like going to the football games on Friday, I would never really be able to know that true value of 70%. It's a guess. I'm inferencing that from a smaller sample that I took. I would never be able to ask all 1,000 students that go to Cornwall High School whether or not they like going to the football games on Friday nights. So because of that, we take what's called a sample, or a smaller portion of the population. And we call that sample a representative sample to make sure that it represents the population. So we're pulling from all the different things that are true about that population, right? If we're talking about Cornwall High School, we'd be talking about students that are in all 4 levels of the classes, juniors, freshmen, seniors, etc. We'd be talking about students of different colors, different religions, different backgrounds, all kinds of different things to make sure that my sample represents everybody that potentially goes to Cornwall High School. And that sample, we then can compute some statistics. And statistics are known for means and proportions. Those two things can be found from that smaller sample. Okay, so let me just give you a kind of overview of what we just talked about there. So first, we have what's called a population. And a population has 2 things that are true about it. A population has a population proportion, which has a fancy symbol, which you've seen, just P. And it has a population mean, another fancy symbol which you might have seen, which is this like fancy U-looking thing called mu. It's a Greek letter. You saw this when we did our distributions in lesson 1 and 2. Okay. These two things are known as parameters. They encompass everything that we know about the population. The problem is these are unknown. I can't find them. I will never be able to find them. They are unknowns. Now, what we can do is we can take a sample of this population. So from this population, we can generate a sample. A sample is representative. I'll help to spell representative, right? Representative of the population. Also, we want to make sure that it is randomly selected. From that sample, say it was 30 students, I can find a proportion or I can find a mean or an average from that sample. So from that sample, we have what's called a sample proportion, which has a fun symbol. It's called P hat, which is P with a little hat on top. And from that sample, we can also find a sample mean, which we know as X bar. Now, once I know a sample, say I have students in Cornwall High School, I want to know what percent of them like going to the football game. I can randomly select 30 students from Cornwall High School, and I find out that 20 of them like going to the football games on Friday nights. That means 67% of my students in Cornwall High School, according to that sample, like going to the football game. So, if we come up with a good randomly selected sample that represents our population, chances are the proportion or the average or mean of that sample is going to be directly the same or close to the population parameters that I don't know. So the last part of this whole thing sums everything together is these two values help determine these two values, or we can use our inference skills to say, since I know the proportion and the mean of the sample, and it's a representative sample, it must also be good for the entire population. So, what do we do? In this course, we use sample statistics to estimate population parameters. This goes back to the fish question we did in the opening exercise. If I wanted to know the average length of fish in the Hudson River, I would never be able to find every single fish in the Hudson River and measure it. I would take a smaller sample, and then I would use my statistical knowledge to inference that sample's value and say, I'm pretty confident that the average fish size in the Hudson River is blank. Now, for today, we just have to understand the difference between these two things. I see the word sample, population. What am I looking for? What am I seeing? What we'll develop over the next couple lessons is how we could actually use these values and make pretty good estimations or inferences as to what these population proportions and means are just by knowing the sample. So, let's take a look at a couple of examples here, and hopefully you understand what I'm talking about here. So it says the manager of a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but fill the cup with a soft drink from the beverage fountain instead of filling the cup with water. I know we all do this. I've done it even. The manager selected a random sample of 80 customers who asked for a water cup when placing an order and found that 23 of those customers filled the water cup with a soft drink from the beverage fountain. Determine the sample mean or sample proportion for this situation. So, first thing we have to identify, is it possible for us to find a mean or an average, or am I going to have to find a proportion for this particular example? Well, if I wanted to find an average, I would need to know a little bit more information. I would need to know how much soda every single one of those 80 customers filled into their cup, and then I can find the average amount of soda. Here I just know that 23 out of the 80 filled with soda, so I can find the sample proportion here. It's a sample because it's not every single customer that walked into the door, right? So every single customer that goes into the fast food restaurant, that's talking about a population. That's a parameter. We don't know that. I have no idea how many people fill their water cup with soda from this restaurant. But I do know there's this one sample. And the sample proportion, which we call p hat, is 23 out of 80. So if we take 23 and divide it by 80, I get 0.2875. This is my population proportion. So about 28.75% of customers that go into this fast food restaurant are going to fill up their water cup with a soft drink if that's what they order. So this statistic is about a sample. But I can use my inference skills to say, because we know this sample's value and this proportion for the sample, I can say it's probably also true for the entire population. That's what we're getting at today. Number 3 says a random sample of 10 words was pulled from the Gettysburg Address shown below. So we have 10 different words here, all of different lengths and number of letters. It says determine the sample mean or the sample proportion for the situation and estimate the true average word length of the Gettysburg Address. So the sample mean is what we're going to use here, because I want to determine the average word length. As soon as I see the word average, I'm thinking sample mean here. So I can determine the sample mean, so the X bar. How do we determine a mean or an average? Well, I'm going to take the number of words, letters in each word, so 3, we have 7, we have 5, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 5, 3, 5, 1, 3, and 6. I'm going to add all those numbers up and divide by the number 10. So I'm going to take the sum of these numbers and add them up. So if I take 3 plus 7 plus 5 plus 10 plus 5 plus 3 plus 1 plus 3 plus 6. I did something wrong. So if I add all those numbers up here, I get 48. Divide that by 10, and I have my sample statistic of 4.8. So what we can see here with these two examples is they're determining two very different things. One of them is determining a proportion of a sample, so what portion of the sample satisfies some condition that we're determining. The other one, the Abraham Lincoln one, is talking about an average, so we're talking about the average length of the words in this Gettysburg Address. Both of them are coming from a sample. Both of them can lead us towards what the population is going to be as well. So because I know that the average word length of this sample of the Gettysburg Address is 4.8, I'm going to go on the assumption of saying the average word length of every word in the Gettysburg Address is 4.8. Number 4 says, Mr. Cromer was interested in the time it takes students to run a mile. He randomly selects 3 sophomore level English classes, and each student reports his or her mile time in seconds. The mean time to run the mile was 498 seconds. Mean, it's a sample, so this is what we call the sample mean, 498. So now we have to determine what's my population and what's my sample. So let's start with the population. That's usually easier to identify those. So the population here is what Mr. Cromer is looking for. So Mr. Cromer is interested in the time it takes students to run a mile. He randomly selects 3 sophomore level English classes, so we're only taking students from the sophomore class, meaning Mr. Cromer is only interested in sophomores. So we are talking about all sophomores at CCHS. If he just selected 3 random English classes, we would say all students at Cornwall Central High School. But since he says specifically 3 sophomore English classes, well, he's taking a small sample of the overall population of sophomores. So what is the sample, right? So the sample are the 3 English classes. Wow. So the sophomore class might be, 250 so students. He's taking 3 English classes, so that might be, around 80 students or so. So he's taking a small portion of the entire population and coming up with this sample. So since the sample population was, the sample mean, or the sample mean here is 498 seconds, what we can conclude is the population mean, which we call mu, is also 498 seconds. We can make that conclusion because of the sample that we took. It was a randomly selected sample. It was representative of the class, and we're going to go on the assumption and use our inference skills to say that the overall population is the same. Number 5 says, Mr. Flannery's AP Stats class is investigating what proportion of the 11th graders at our high school are taking at least one advanced placement course. The students went to guidance and got a list of 265 juniors at Cornwall High School and numbered them 1 to 265. A random number generator was used to select 40 students. So I'm randomly selecting a group of juniors, and I'm randomly selecting them using a random number generator, so I'm going to have a good representative sample. So our sample is going to be good, and it's going to represent our population nicely. They found that 14 of the 40 students were enrolled in an AP course. Determine the sample proportion for the juniors taking the course. So the sample proportion is 14 out of 40. Right, so our p-hat, so we could say 14 divided by 40, we'll even make it a nice little decimal, 0.35. So about 35%. Identify the sample and the population. So the sample is the 40 randomly selected students, and the population are the junior class at CCHS. Right, we only pulled from juniors. We're not pulling from all students at Cornwall Central High School, so that's all they are interested in. So what conclusion can Mr. Flannery's class make about the population? So what he can say here is approximately 35% of juniors at CCHS are in AP courses. Again, we're using the same data, right, that same number to represent our population because our sample was a good randomly selected representative sample. We will see as we move on that these samples are going to tell us different things, and we can kind of make more inferences and guesses about our populations. But for right now, if it's a good randomly selected representative sample, the sample's going to give me the population mean or population proportion. Hopefully this video helped, and I will see you soon.